Welcome back, longevity seekers. Today we're delving into groundbreaking research that has the potential to revolutionize how we approach aging and age-related diseases. Imagine a future where we could eliminate the cells that make us old, rejuvenating our bodies and significantly extending our health span. This potential to extend our health span is not just exciting, it's a paradigm shift that could change the way we age. So fasten your seatbelts because that future might be closer than we think. We're exploring a fascinating study that combines two cutting-edge fields, senescent cell removal and CAR T-cell therapy. Now, I know that might sound like a mouthful, but stick with me. This could be the key to unlocking a healthier, more vibrant future for all of us. Let's start with the basics. As we age, our bodies accumulate what scientists call senescent cells. These are like the grumpy old neighbors of the cellular world. They don't function properly anymore, but they refuse to die and move out. Instead, they hang around, causing inflammation and contributing to various age-related diseases. Wouldn't it be great if we could evict these troublemakers? That's where CAR T-cell therapy comes in. CAR stands for chimeric antigen receptor, and it's a technique that's already known in the cancer treatment world. It involves reprogramming our immune cells to recognize and attack specific targets. In this case, researchers have engineered these cellular superheroes to hunt down and eliminate senescent cells. The star of our show today is a protein called uPAR. Think of uPAR as a bullseye that appears on senescent cells as we age. The researchers created CAR T-cells targeting this protein, turning them into precision-guided missiles against aging cells. Now here's where it gets fascinating. The team tested these souped-up immune cells in mice, and the results were nothing short of amazing. They found that a single treatment with these uPAR-targeting CAR T-cells could significantly reduce the number of senescent cells in various tissues, including the liver, fat, and pancreas. But it's not just about eliminating old cells, it's about what happens when they're gone. The treated mice showed remarkable improvements in several hallmarks of aging. They had better glucose tolerance, meaning their bodies were better at managing blood sugar levels. This is huge because poor glucose management is a critical factor in type 2 diabetes, a common age-related disease. The treated mice also displayed improved exercise capacity. Imagine being able to bound up the stairs or play with your grandkids without getting winded. That's the kind of real-world impact we're talking about here. What's truly mind-blowing is the longevity of the effect. Unlike many treatments that require constant administration, these CAR T-cells persisted in the mice's bodies for over a year, continuing to patrol for and eliminate senescent cells as they appeared. It's like having a permanent anti-aging squad on duty in your body. But wait, there's more. The researchers continued treating already aged mice. They also gave young mice a single dose of these CAR T-cells and followed them as they aged. The results were astounding. These mice were significantly protected against age-related decline. They maintained better metabolic health and physical fitness as they grew older than their untreated counterparts. I know what you're thinking. This sounds too good. What about side effects? Surprisingly, the treatment appeared to be well tolerated. The mice showed no significant adverse effects, even when the researchers closely examined various organs and blood parameters. Let's take a moment to appreciate the elegance of this approach. Instead of trying to fix each symptom of aging, this therapy targets the root cause, the accumulation of senescent cells. It's like pulling out a weed by its roots instead of trimming the leaves. However, the implications of this research go beyond just treating natural aging. The team also tested their CAR T-cells in a model of obesity-induced metabolic syndrome. They found that the treatment could reverse many of the metabolic disturbances caused by a high-fat diet. This suggests that this approach could help combat aging and lifestyle-related health issues. Now I can see you longevity seekers getting excited, but let's pump the brakes for a second and talk about what this means for humans. As groundbreaking as this research is, it's important to remember that it was conducted in mice. While mice are a good model for many aspects of human biology, they could be better analogs. We still need to do a lot more research before we can say whether this approach will work in humans, and if it does, whether it will be safe. Now imagine the potential for this research to inspire healthier living. If we could develop a similar treatment for humans, we might be able to delay or even prevent many age-related diseases, from diabetes to heart disease to neurodegenerative disorders. This potential to avoid these diseases is not just fascinating, It's inspiring. It could significantly improve our quality of life as we age, motivating us to live healthier and more fulfilling lives. Consider the potential societal impact of this research. If people can maintain their health and vitality well into their later years, it could transform our perception of retirement, healthcare, and the quality of life for older adults. We could witness 80-year-olds running marathons or embarking on new careers. The economic and social implications could be profound, ushering in a new era of engagement and productivity in our aging population. But let's dig a little deeper into the science. One of this study's most intriguing aspects is using uPAR as a target. The researchers found that uPAR levels increase with age in various tissues, and that most senescent cells express this protein. This suggests that uPAR could be a universal marker for senescent cells, crucial for developing a broadly effective therapy. The study also sheds light on the types of cells that become senescent with age. They found that different tissues had different profiles of senescent cells. In the liver, for example, many senescent cells were endothelial cells, which line blood vessels, and immune cells. In fat tissue, they were often pre-adipocytes, precursors to fat cells, and specific immune cells. This detailed information is vital for understanding how senescence contributes to different aspects of aging and age-related diseases. Another fascinating aspect of the study is the long-term persistence of the CAR T cells. In cancer therapy, CAR T cells often decline over time, requiring repeated treatments. However, in this study, the cells persisted and even expanded over time, presumably because the presence of new senescent cells continually stimulated them. This suggests that a single treatment could provide long-lasting benefits, a massive advantage in effectiveness and practicality. The researchers also explored the preventive potential of this therapy. Treating young mice before they develop age-related issues could significantly delay the onset of metabolic dysfunction and decreased physical fitness. This raises the tantalizing possibility of using such a therapy not just to treat aging, but to prevent its adverse effects in the first place. Now let's discuss some of the remaining challenges and questions. One of the big ones is safety. While the treatment appeared well tolerated in mice, we need to be sure it wouldn't have harmful effects in humans. Therapies that modify immune cells always have a risk, as they could potentially attack healthy cells or cause excessive inflammation. Another question is whether eliminating senescent cells could have any negative consequences. While these cells are generally considered harmful, some research suggests they play essential roles in specific contexts, such as wound healing. We need to understand more about the complex biology of senescence to ensure we're not throwing out the baby with the bathwater. There's also the question of delivery. In this study, the CAR T cells were administered intravenously, but would this be the best method for humans? Could we develop more targeted delivery methods to focus on specific tissues or organs? Despite these challenges, this approach's potential is enormously exciting. It represents a shift from treating the symptoms of aging to addressing one of its fundamental causes. And unlike many anti-aging approaches requiring continuous treatment, this could provide long-lasting benefits from a single administration. Moreover, this research opens up new avenues for exploration. Could we identify other markers of senescent cells and develop even more precise targeting methods? Could we combine this approach with other anti-aging therapies for even more significant effects? The possibilities are truly mind-boggling. All right, longevity enthusiasts, let's dive into what's on the horizon for this exciting research. The authors have given us some tantalizing hints about their next steps. They're not content with tackling metabolic dysfunction. Oh no. These scientists have their sights set on exploring how uPAR CAR T cells could combat a range of age-related conditions. Imagine the possibilities. They're also keen to unravel the mystery of which specific uPAR-positive cells are the real important players behind our improved metabolic function. But it gets intriguing here. They're discussing developing tissue-specific senolytic antigens. That's right, we could be looking at designer CAR T cells tailored to target aging in different body parts, while they're still getting ready to leap into human trials or more extensive animal studies. The focus is on expanding our understanding of this technology's potential. It's like they're fine-tuning their anti-aging orchestra before the big performance. Stay tuned because the future of longevity research is looking brighter than ever. As we wrap up, let's take a moment to appreciate the broader implications of this research. It's not just about living longer, It's about living better. It's about maintaining health, vitality, and independence as we age. It's about redefining what it means to grow old. Imagine a future where 80 is the new 50, where our later years are filled with vitality and new experiences rather than decline and disease. Imagine the wisdom and contributions our societies could benefit from if people could remain healthy and active for decades longer than they do now. Of course, we're not there yet. This research, exciting as it is still in its early stages. We need more studies, including human trials, before we can say whether this approach will live up to its promise. But it gives us a tantalizing glimpse of what might be possible. So, my fellow longevity seekers, while we can't run out and get this treatment today, we can take heart in the rapid progress in aging research. Studies like this one are pushing the boundaries of what we thought was possible, bringing us closer to a future where aging is not an inevitable decline, but a manageable process. As we look to that future, it's important to remember that there's plenty we can do to support our health and longevity. Eating a healthy diet, staying physically active, managing stress, and getting enough sleep are all proven ways to support healthy aging. Think of it as laying the groundwork for the anti-aging treatments of the future. In the meantime, we'll be here keeping you updated on the latest breakthroughs in longevity research. Who knows? The next time we meet, we might discuss the first human trials of Senolytic CAR T-cell therapy. Until then, keep seeking, learning, and believing in the possibility of a longer, healthier future. The best is yet to come. Thanks for joining us today. I hope you got a ton of value from our video. Stay curious and healthy. We'll see you in the following video.